On graph paper, please draw a segment AC, and it has coordinates at 2, 6, that's where A is, and C is at 5, 1. So I'm going to start by sketching A, which is at over 2 and up 6 units. So here's 2 and then 6. So this should be the point A, which has coordinates of 2, 6. The next thing is C, the other end of this line segment, and it has coordinates at 5, -1. So this point is C, and its coordinates are at 5, -1. Now, if I sketch this as a segment, I should draw the line that connects those 2 points. There we go. And next it says, then draw a slope triangle. So if I'm doing this, from here I would go down to this point and then over, and let me just kind of sketch this here, right? So here's one side of this slope triangle, and here's the other. And because these lines are, one's parallel to the y-axis, one's parallel to the x-axis, those two segments in our slope triangle there are definitely perpendicular to each other. And it says use this slope triangle then to figure out the length of our original segment AC. So if I'm taking a look at this, this is 7 units long, right? It's traveling from 6 down to -1. So I could say 6 minus -1. That's 7 units long. Now it is going, in the down direction. 6 minus -1. Definitely going downwards. And 5 minus 2, no, 2 minus 5, if I'm doing the same direction, 2 minus 5, that would be a -3. This is terrible looking, but I would call that -3. But that would be if I was finding the slope of it. I'm actually finding the lengths of these pieces. So my slope I could write as 7 over -3, or if I flip the point direction, I could do 7 or -7 divided by +3. But in either case, right, the slope is down 7 units over 3. So it's a slope of -7/3. The important part for this problem is what's the length of AC? So I'm just going to use the Pythagorean theorem. I think most of you have seen this before. There's definitely a big poster for this up in the classroom, and just continue to think about and develop your skill at using this. So it says that if you take the legs of a right triangle and you square them, right, leg squared plus the other leg squared, it will equal the hypotenuse, which I've labeled x in this diagram, squared. So the 7 squared is 49, and the 9 squared, the 3 squared is 9, and that equals x squared. 49 plus 9 is 58, and that is what x squared is. So there's two solutions to this, right? Plus and negative root 58. But I only care about the positive root. So in fact, let me take a look at that as a decimal. The square root, let's see, second square root of 58, I get this thing, right? 7.615, etc. So x is approximately 7.615. Now, the problem says also to consider the precision of your measurement. So I've looked at the book and I don't know that they've talked about this a whole lot, but let me just share with you my understanding of precision. If you look at this, the dimensions of the two legs were given to the nearest whole number, right? 7 and 3. If your dimensions of your triangle are given in whole numbers, you should be using that as the dimension for your answer. So or the rounding for your answer. So I would be inclined to say that my answer here is x is approximately, and I'm going to round up to the next whole number, is approximately 8 units. Clearly that's a little big, right, because it's 7.6 something, but just based on the precision of these units, 7 and 3, I would be inclined to round it this way to the nearest whole number. Now, for some reason, if we had more precision, if these coordinates were a little bit more accurate and they said that this was like 3.2 and maybe this is 7.1, something along those lines, then I would be inclined to give you an answer to the nearest tenth, right? So in general, go ahead and give your answer to the same level of precision as the inputs to your calculation. You can see here the inputs to my calculations were whole numbers, 7 and 3. So my output should reflect that, right? My output x is approximately 8 units.